Hi, this is Mr. Razak here, and today we're going to continue looking at mathematics on the coordinate plane, and in this video we're going to take a look at the slope of a line and an equation of a line on a coordinate plane. If you remember from a previous video, we can have an infinite amount of points on a coordinate plane, and any 2 points on a coordinate plane can be connected with what's known as a line. So this shape, this figure that looks like a line is actually a line on a coordinate plane, and the line is a very specific shape that describes the locations of a whole family of points on a coordinate plane. So the first thing that we probably would want to know about a line on a coordinate plane is essentially the answer to a question: how fast does it rise? If you, for instance, look at those 3 lines, they all start in the same point and they all go through a different point to form the line. And you can say that each of those lines raises at a different rate. This line raises quite fast, this line raises a little bit slowly, and this line raises very, very slowly. And the horizontal line doesn't rise at all. And the vertical line has, you could say, that a very, very, almost an infinite rate of raise. In any case, we can talk about how fast does each of those lines raise using this parameter called the slope. And in order to find the value of the slope, we need the following. We need to find out the locations of the points between which the line is drawn. So we need the coordinates of the 2 points. And if we have the coordinates 2 points, we need to find out how far are those points located from each other along the horizontal axis. So we need the horizontal distance. And we also need to know how far are those points located away from each other along the vertical axis. So we need the vertical distance. To find the horizontal distance, we subtract 2 horizontal coordinates, the 2 x coordinates. To find the vertical distance, we subtract the 2 y coordinates. And in order to find the slope, what I'm going to do, I'm going to divide the vertical distance over the horizontal distance. Or in other words, you can remember this as rise over the run of the line. And what the slope tells me is by how much does the vertical distance change for each unit change of a horizontal distance. And essentially that's what the slope is. It tells you how fast does the function increase. So here I have an example of a line. Line goes through 2 points. The first point with coordinates of 1 and 1, and the second point with coordinates of 2 and 3. And in order to find the slope, the first thing I need to find is the vertical distance between the 2 points, and the second thing is the horizontal distance between the 2 points. So for the vertical distance, I'm going to subtract y2 minus y1. y2 will be 3 and y1 will be 1. I always write down the coordinates above, the names above the coordinates. And in a similar fashion, I'm going to subtract x2 minus x1. So this is x2 and this is x1. And the reason why I call them y2 and x2 and y1 and x1 is because this point is the first point and this is the second point. And this is the reason why I call those points x2 and x1. So in any case, the vertical distance y2 minus y1 equal to 3 minus 1 equals to 2. And the horizontal distance x2 minus x1 equals to 2 minus 1, 1. Which means that slope is equal to 2. What I want to point out is that the value of the slope in here is positive, which means that the function is increasing. The value of the slope could also be negative, which would mean that the function is decreasing. And also, actually interestingly, the value of the slope could also be equal to 0. If the value of the slope is equal to 0, it means that the function is not increasing. It's just a horizontal line. But these are the 3 things we should remember about the nature of the slope. And the slope is a characteristic that we are going to use in order to find equation of a line. So why do we need something like an equation of a line? Well, perhaps a good way to explain it would be to take a look at the number of points on a single line. So here I have a line and I mark the number of points on that line. And if I take a look at how do the x coordinates and the y coordinates relate to each other, I'll notice that there is a pattern. So for instance, for x coordinate equal to -2, my y coordinate is equal to -1 from this point. For -1, y coordinate is equal to 0. For 0, y coordinate is equal to 1. For 1, it's equal to 2. And for x equal to 2, y coordinate is equal to 3. Now, if you take a look at those numbers, x numbers, and take a look at y numbers, you'll be able to write down an equation that describes this pattern, because there is a pattern in those numbers, there is a regularity, and the regularity can be described that the x number increases by 1 to give us the y number. So I could write this down as y equals to x plus 1. That's the equation of this line. The equation of the line describes the regularity that occurs for all the points that are on the line, describes the pattern that all the points on that line follow. And the pattern on the line y equals to x plus 1 is that y coordinate is equal to x coordinate plus 1. So for our previous example, where we calculated the slope of a line, we can use the slope of that line in order to find out what the equation of this line would be. And for this, we're going to use a point slope formula. So if you use the point slope formula, we need the slope, and slope we already calculated for our example line. And we're going to use this formula in order to calculate or figure out what the equation of a line is. This is an approach that we can just remember to use. And what it means is that we're going to find out the relationship between y and x numbers for each of those each of the points on the line. And to do that, we need coordinates of one point of the line. So that y0 and x0 are coordinates of a single point on a line. So here I have x0 equal to 1 and y0 equal to 1 as well. So these are coordinates of a single point on the line. And I need coordinates of a single point of a line if I want to use the slope point approach. Obviously, the name itself suggests that I need the value of the slope. And the value of the slope I calculated already. So then, through substitution, I put in y0 from the point, y0 equals to 1, and note that because the point is positive, I don't change the sign. And similar way in here for x0, the coordinate of the point is positive, so I don't change the sign. So I have that y minus 1 equals to 2x minus 1, and this describes the pattern that all the points on this line will follow. So then if I simplify it a little bit, on the right hand side multiply across in the bracket, that will give me 2x minus 2. And then if I move the number from if I move the number on the right hand side, on the left hand side onto the right hand side, I'm going to get the slope intercept formula for this particular point. So if I calculate it all, I'm going to arrive at a formula of a line, y equals to 2x minus 1. And that formula corresponds to a more general formula of a line called the slope intercept formula. So on the slope intercept formula, I get two parameters of a given line. I'm going to get the slope of that line, and I'm also going to have the number c tells me the y coordinate of number c tells me the location along the y-axis where the line cuts through that axis. So for instance, in our case, that number c is equal to -1, and you can see that the line cuts the y-axis at the coordinate of y equal to -1. So number c tells me where the line cuts through the y-axis, and that's why this is called the slope intercept formula. There are other ways to describe a line using different approaches. So the first one we have this. So there are other ways of describing a line on a coordinate plane. The first one, the slope intercept formula, we already know. In the slope intercept formula, the number that's attached to the x tells us the slope of a line, and the number that's beside the x tells us where does the line cut the y-axis. Note that there is no coefficient beside the number, the y variable, and that number is also positive. So only if the y number is the y variable is positive can we talk about the slope-intercept formula. And we'll often have to transform different types of formulas in order to arrive at this one. Then another way to describe a line is using point-slope formula. So for point-slope formula, I need the slope parameter of that line calculated using the slope formula, and I also need coordinates of one point on that line, and in this case the coordinates of that point are 1 and 1. And finally, both the slope-intercept formula and point-slope formula can be transformed to a general equation of a line. And general equation of a line is an equation of a very similar nature as a general equation of a general quadratic equation, where it consists of x variable with a coefficient, y variable with a coefficient, and a constant. So general equation of a line has a general form a x plus by plus c equals to 0. And I would recommend that you remember this, both of those, the general formula and what is the equation of this line in general form, so that you can transform slope-intercept or point-slope into general equation of a line, or vice versa. And this is something we're going to practice. So to sum up, in today's video we talked about the slope of a line, we talked about the equation of a line, and we discovered what are the three common ways of describing lines on a coordinate plane. So thank you for watching. I appreciate your time and attention. This is Mr. Oziak, out.